In this lesson, we are going to find limit of a function as x approaches either positive or negative infinity. When we say x approaches infinity, that means x is getting bigger and bigger to the right side. We say limit of f of x as x approaches infinity is infinity when f of x is getting bigger and bigger as x is getting bigger and bigger. We say limit of f of x as x approaches infinity is L when f of x can be as close as possible to L as we want to when x is bigger than any real number. To understand this, let's find limit of x2 plus 3 as x approaches positive infinity. When x approaches positive infinity, that means x is getting bigger and bigger. In this case, x2 is getting bigger and bigger. Therefore, x2 plus 3 is a big positive number. Limit of 1 over x as x approaches positive infinity. When x is getting bigger and bigger, 1 over x is getting smaller and smaller. This means when x approaches infinity, 1 over x approaches 0. Let's have a geometric interpretation for these two examples. Let's sketch the graph of x2 plus 3. It's a parabola upward. And as you see, when x is getting to positive infinity, y also is getting to positive infinity. Graph of 1 over x. When x moves to the right side, 1 over x is getting close to 0. Similarly, we can talk about limit of f of x as x approaches negative infinity. This means x moves to the left, and absolute value of x is getting bigger and bigger. By looking at the graph of 1 over x, y equals 1 over x, we see when x approaches negative infinity, limit of 1 over x is also 0. For polynomial functions, px equals a n xn plus a n minus 1 x to the power of n minus 1 plus a1x plus a0, a n xn is called the dominant term. A n is called the leading coefficient. Limit of px when x approaches infinity and limit of a n xn the dominant term as x approaches infinity are the same. This could be when x approaches positive or negative infinity. To prove this property, we say limit of px as x approaches infinity is the same as limit of xn times an plus an over x plus a0 over xn. As x approaches 0, limit of an minus 1 over x is 0. Limit of an minus 2 over x2 is also 0. Similarly, limit of an over xn is 0. This means limit of p of x as x approaches infinity and limit of an xn as x approaches infinity are equal. Thank you.